Now then, what have we got in the possibilities hoard? We have a Sealey 1/2" drive impact. Quite a lot of gravity about it, which is great, and it says 325 pounds-foot. Okay, and I picked this up a while ago with the battery, but the battery, I can't read it. Hang on a minute. Let's get the super glasses out. It doesn't actually say whether it's nickel metal hydride or nickel cadmium. Alright. Oh, it does. It says NiCad. Yeah. About as much use as a poke in the eye with a pointed stick. But it's sort of, I've given it a little charge, but when you try and take much power out of it to undo a nut, it dies. But the beauty of it is we have got this bit. Yeah, the connection and that. So we can hack this apart and use that as a frame for something else. With that, we can either put other batteries in there, or again in the possibilities hoard, we've got a Parkside. Now, all the lights light up, but these don't have the capacity. Right, okay, now I'm going to do some experiments here, but I think I've worked out why it doesn't have the capacity. I've got this one, which is a number 2. I've got this one, which is a, it's got a tick just there, and then we got this one, which has got a number 1. Now, I know the one with the tick is almost as new, so I'm just going to put these in there. I think we should zoom down a bit now. Okay, so where are we? That's the positive, that's the negative, and here we've got the meter set on 200 DC. Can we see? Yes, we can. And this is the good one. It shows 20.7. I think you saw that, but let's just... Is that any better? No, it's not. That's better down like that. .6. Okay, right, that's recently charged. Now this is one, this is number 2, that's been recently charged. Initially it didn't really, the charger didn't like it, but then it went, oh alright then. That's 20.3. And where's this one? That's number 1. There we go. That's 19.5. And that one was recently charged. Yeah. So we got a problem there. So let's take it apart. Just adjust things and zoom out a bit. They do come apart reasonably easily, and this is a torque screw. Okay, I don't know what number it is. Doesn't actually say on it. Anyway, so let's find out where the voltage and the capacity have disappeared to. Okay, as you can see, these come apart, as I said earlier, reasonably easily, and that just lifts out. Yeah, but we'll do that later. Meter, stick it on 20. You might be able to see this. Okay, 4.04, 4.03, 4.04, 4.04, 3.49, the end one. Now, we can either change that cell, or we can put that on the bench power supply and try and bring it back to life. Because it's not dead, but it's a bit low compared to the rest. And I suspect what's happened with this one is people have used whatever piece of equipment it was driving until the battery switched off, and then charged it up and then did it again and again and again and again, and of course that will identify a slight weakness in one of the cells. Really don't run these batteries until the BMS switches off. Run them and then charge them up. In my opinion, I think that's looking after the cells, because all the rules with solar equipment, etc., solar batteries, is don't run them till they're flat. Yeah, and I think it's the same with these. If you do, you get an imbalance build up, despite what the BMS possibly can do, because the BMS, it doesn't affect the charging. All it does is reduces the voltage of the highest cell. Yeah? So a low cell can stay low if you constantly deep cycle it. So I'm going to put this on the bench power supply for probably 4 or 5 hours at maybe 300 milliamps, something like that. Yeah, so I'll let you know how that turns out, and then we will continue. Otherwise, we'll remove the cell and replace it with a cell out of this, which is out of a Dyson. Now, as we all know, Dyson batteries are a bit rubbish. 4.25. These have not been charged up. Let me try and get a good 4.27. 4.27. 4.27. 4.08. 0.6. So the end cell is dull. Yeah, and of course one of the problems with Dyson is not only do the BMSs not behave themselves, but the on-off switch, or the actuator, is just there, and it's part of the BMS. So there's no actual switch on the machine. All there is from the trigger is a mechanical link to that. So you can't just go, oh, there's a switch on the machine, I'll put whatever battery I want on there. No, because it's all part of that. So very, very nasty. Anyway, so we've got a potential cell there that we can rob out of that. Yeah. So the cells are good in these, and I think they're, can't remember, 3.5 amp hour or something like that. Yeah. So we got a donor if we need it, but I'm going to charge that one up, yeah, and we'll go as far as we can see. Now whilst we're here, so I'm going to lift that out, okay, and there we are. There's a spring for this, yeah, and that bit that's the indicator. So we're going to, there is the positive and there's the negative. So I'm just going to lift that up slightly so I can slide a bit of something in there to attach there, or I can attach there and there. Yeah, I think we can go there and there off the bench power supply and charge that cell up. Now I'm just going to make sure we're going to be charging the right cell up. No, we're not. It's that one. 3.49. That one's 4.03. So it's not this end, it's that end. Always worth checking. So that is the positive and that is the negative. So the negative is the case and the positive is the center terminal. Yeah, so we're going to charge that up and I'll get back to you. So there we go, attached and attached, and let's zoom out. And we're charging at about 350 milliamps. Forget the voltage at the top because it's not as accurate as I'd like it to be. Yeah, it's a little bit on, it shows a bit higher than it actually is, but this milliamps, it is limited. You see that little LED on there, so it's limited to that. So hopefully we will boost the voltage in that cell up to 4.1, something like that, and then we will continue. Several days have gone by, so I charged this cell at the end up to 4.17. yeah, 4.15. okay, so it's not self-discharging, but the rest are, where are we, 4.04. so I need to bring this one down a bit to create the balancing. So we've got a headlight bulb here. There we go. So we just need to, right, how are we going to do this? Will that fit on? That will fit on there. And that will fit on there. Oh, there we go. And then we can, oh, it's pulled it down to 4. But it will bounce back up again. Yeah. So we just need to give it a bit of load just to bring it down a little bit, to level it out. We don't want to start with uneven voltages. As I said before, the balancing only reduces the voltage of the cell with the highest voltage. That's right, only the one with the highest, and it puts a little resistance across it. So if you're way out, like this one was, there's no way that one will catch up at all. Yeah. So we've been through the causes of that. Don't need to do that again. Right, we got, and it's going to bounce back up a little bit. What voltage have we got on this? I'm assuming you can see the multimeter. Yes, you can. So we'll just leave that for probably a minute or something, just to, and then we can put this back in place. Now, the question is, how am I going to attach this to that impact driver whilst I can still connect it to the charger? I'm thinking to drill a little hole through there and bring cables out. I did see on eBay an adapter which was to go to here, and then it has cables that come out, but it's £10, and if I knew this would work then that would be great, but I want to do a test because we are running that impact at slightly lower voltage. .04, 4.05. I think that will be right. Okay, we've done a little bit of balance in there, so I'm going to put that back together. That goes in there like that. So I could drill a hole in the side here, couldn't I? That is the positive, so I could drill a hole there, and that is the negative, so I could drill a hole somewhere in here. Not quite sure what this extra piece is for, so that goes in there. I mean, these go in really nicely, and we've got the spring in place, yeah, for this catch. Yeah, I mean, look how well that goes together compared to a Makita one where you really have to quite struggle. But then the Makita one does have 2 rows of cells in parallel, so it's a deeper container, as it were. So we can come out of there, and we can come out of there. Perhaps just a little notch in that join. Now, which way round does this go? There's the narrow one, so that goes there. Look at that, isn't that beautiful? A little notch there and a little notch there, and we're away. Okay, I don't think you need to see that. You see the principle. I'm going to mark it out, just create a little nibble, and then get some reasonably fat wire, solder it on, and you know, I can always take the wire out later and bung a little bit of silicone or some sort of filler in that little hole. What's not to like? In fact, little hole there and there. Yeah, nice one. Right, back to you shortly. Okay, so I've soldered that on there. Yep, on the negative and on there, and I found the best way is to bring them out like that and just create a notch there on the opposite corner with the Dremel, and then just file it out. Okay, and then there is a right way and a wrong way round with these. I think it goes that way. Is that right? Those there go there. So it's that way around. That against there. And you just bolt it upright. So I'm just going to bolt that up. And then I'm going to stick this in the charger and let it get to full whack. So let's just switch the charger on. There we go. And it's charging away. Now, when I soldered those cables on, I did use a bit of extra flux. Just a little, half nothing, but it makes such a huge difference, and you hardly put any heat into the battery that way because the solder takes very quickly. So a bit of just a wipe of flux and then use cord solder and it's easy, a lot quicker. So we'll just leave this now to charge fully up, and we'll go as far as we can see. And luckily now we've got tails on this battery, we can see what the voltage is. I imagine a 20 volt battery will charge to 21, 22 volts, something like that, because it always, you charge at a higher voltage slightly than you want. So what are we showing at the moment? .9 at the moment. Hopefully you could see that. Yeah, and it will go up some more yet. Right, grand. Okay, we've got this latch together in test mode. Yeah, and this bolt here is rusted solid. So let's see what we can do. This is testing not only this impact but this battery. Right, let's have a look. Wow. Apart from the battery falling out, that undid that rusty bolt. So let's just put this clip back on. And the other thing that Owen suggested is to undo a wheel nut. Okay, so the battery connection is obviously a bit duff, but it did it. So I'm going to test this on other wheel nuts and just see the longevity of this battery. I'll be back to you in a minute. Okay, we've undone 10 wheel nuts, and let me just see if you can see the indicator. So that's pretty good. Now the question I have for people is, what's this screw for? Is it adjusting torque or something like that? Anyway, if somebody can get back to me on that. And that is a Sealey CP240, but the last bit has been worn away. Okay. Comments? Obviously this is going to be upgraded and I'll do a fresh video on upgrading that, but seems to work. Undoes a rusty bolt, undoes wheel nuts that have been torqued up fairly well. What's not to like? Recycled battery or repaired battery, yeah, So the only cost will be some sort of arrangement here. Right, comments, discussion, catch up with you soon.